Triangles. A closed figure consisting of three line segments linked end to end is a triangle. It's also called a three-sided polygon. Vertex. The vertex is a corner of the triangle. Every triangle has three vertices. Base. The base of a triangle can be any one of the three sides, usually the one drawn at the bottom. You can pick any side you like to be the base. Commonly used as a reference side for calculating the area of the triangle. In an isosceles triangle, the base is usually taken to be the unequal side. Altitude. The altitude of a triangle is the perpendicular from the base to the opposite vertex. The base may need to be extended. Since there are three possible bases, there are three possible altitudes. Three altitudes intersect at a single point called the orthocenter. Median. The median of a triangle is a line from a vertex to the midpoint of the opposite side. The three medians intersect at a single point called the centroid of the triangle. Each median divides the triangle into two smaller triangles which have the same area. Because there are three vertices, there are of course three possible medians. No matter what shape the triangle, all three always intersect at a single point. This point is called the centroid of the triangle. The three medians divide the triangle into six smaller triangles of equal area. The centroid, point where they meet, is the center of gravity of the triangle. 2/3 of the length of each median is between the vertex and the centroid, while 1/3 is between the centroid and the midpoint of the opposite side. So m is equal to square root of 2b square plus 2c square minus a square by 4, where a, b and c are the sides of the triangle and a is the side of the triangle whose midpoint is the extreme point of median m. Area. The number of square units it takes to exactly fill the interior of a triangle. Usually called half of base times height, the area of a triangle is given by the formula A is equal to HB by 2. Other formula is P into R by 2. A is equal to ABC by 4R, where B is the length of the base, A and C the other sides, H is the length of the corresponding altitude. R is the radius of circumscribed circle, and capital R is the radius of circumscribed circle and small r is the radius of inscribed circle. P is the perimeter. Another important formula called the Heron's formula or Hero's formula for calculating the area is A is equal to square root of S into S minus A into S minus B into S minus C, where A, B, C are the three sides of the triangle and S is equal to A plus B plus C by 2, which is the semi-perimeter of the triangle. Perimeter is the distance around the triangle, the sum of its sides. For a given perimeter, equilateral triangle has the largest area. For a given area, equilateral triangle has the smallest perimeter. Relationship of the sides of, let us look at the relationship of the sides of the triangle. The length of any side of a triangle must be larger than the positive difference of the other two sides, but smaller than the sum of the other two sides. Interior angles. The three angles on the inside of the triangle at each vertex are the interior angles. The interior angles of a triangle always add up to 180 degrees. Because the interior angles always add to 180 degrees, every angle must be less than 180 degrees. The bisectors of the three interior angles meet at a point called the incenter. which is the center of the incircle of the triangle. Exterior angles. The angle between a side of a triangle and the extension of an adjacent side. An exterior angle of a triangle is equal to the sum of the opposite interior angles. If the equivalent angle is taken at each vertex, the exterior angles always add to 360 degrees. In fact, this is true for any convex polygon, not just triangles. Mid-segment of a triangle. A line segment, mid-segment of a triangle is a line segment joining the midpoints of two sides of a triangle. A triangle has three possible mid-segments. The mid-segment is always parallel to the third side of the triangle. The mid-segment is always half the length of the third side, and a triangle has three possible mid-segments depending on which pair of sides is initially joined. So you can see the illustration for the mixed segment here. So the triangle has three possible mid-segments depending on which pairs of the sides we join. The relationship of sides to interior angles in a triangle. The shortest side is always opposite the smallest interior angle. The longest side is always opposite the largest interior angle. Angle bisector. An angle bisector divides the angle into two angles with equal measures. An angle only has one bisector. Each point of an angle bisector is equidistant from the sides of the angle. The angle bisector theorem states that the ratio of the length of the line segment BD to the length of the segment DC is equal to the ratio of the length of side AB to the length of side AC. BD by DC is equal to AB by AC. The incenter is the point where the angle bisectors intersect. The incenter is also the center of the triangle's incircle, the largest circle that will fit inside the triangle. Similar triangles. The two triangles are similar and all of the sides of the larger triangle are twice the side of the corresponding legs on the smaller triangle. If two similar triangles have sides in the ratio x by y, then their areas are in the ratio x square by y square. Congruence of triangles. Two triangles are congruent if their corresponding sides are equal in length and their corresponding angles are equal in size. SAS side angle side. If two pairs of sides of two triangles are equal in length and the included angles are equal in measurement, then the triangles are congruent. SSS side side side. If three pairs of sides of two triangles are equal in length, then the triangles are congruent. ASA angle side angle. If two pairs of angles of two triangles are equal in measurement and the included sides are equal in length, then the triangles are congruent. So, knowing SAS or ASA is sufficient to determine unknown angles or sides. Note important exception. The SSA condition side-side angle, which specifies two sides and a non-included angle, also known as ASS or angle side-side, does not always prove congruence. even when the equal angles are opposite equal sides. Specifically, SSA does not prove congruence when the angle is acute and the opposite side is shorter than the known adjacent side but longer than the sine of the angle times the adjacent side. This is the ambiguous case. In all other cases with corresponding equalities, SSA proves congruence. The SSA condition proves congruence if the angle is obtuse or right. In the case of the right angle, also known as the hypotenuse leg, HL condition or the RHS condition, we can calculate the third side and fall back on SSS. To establish congruence, it is also necessary to check that the equal angles are opposite equal sides. So, knowing two sides and non-included angle is not sufficient to calculate unknown side and angles. Angle. AAA says nothing about the size of the two triangles and hence proves only similarity and not congruence. So knowing three angles is not sufficient to determine lengths of the sides. The kinds of triangles. A scalene triangle is a triangle in which all sides and angles are different from one another. All properties mentioned above can be applied to the scalene triangle, if not mentioned the special cases, equilateral, etc. Equilateral triangle, all sides have the same length. An equilateral triangle is also a regular polygon with all angles measuring 60 degrees. The area is A is equal to A square into root 3 by 4. The perimeter is P is equal to 3A. The radius of the circumscribed circle is R is equal to A into root 3 by 3. The radius of the inscribed circle is R is equal to A into root 3 by 6. And the altitude is H is equal to A into root 3 by 2, where A is the length of a side. For any point P within an equilateral triangle, the sum of the perpendiculars to the three sides is equal to the altitude of the triangle. For a given perimeter, equilateral triangle has the largest area. For a given area, equilateral triangle has the smallest perimeter. With an equilateral triangle, the radius of the incircle is exactly half the radius of the circumcircle. An isosceles triangle is a triangle in which two sides are equal in length. An isosceles triangle also has two angles of the same measure, namely the angles opposite to the two sides of the same length. For an isosceles triangle with given length of equal sides, right triangle has the largest area. To find the base, given the leg and altitude, use the formula b is equal to 2 root over L square minus A square. To find the leg length, given the base and altitude, use the formula L is equal to root over A square plus B by 2 whole square. To find the altitude given the base and leg, use the formula A is equal to root over L square minus B by 2 whole square, where L is the length of a leg and A is the altitude and B is the length of the base. Right triangle. A triangle where one of its interior angles is a right angle or 90 degrees. Hypotenuse. The side opposite to the right angle is the hypotenuse. This will always be the longest side of a right triangle. The two sides that are not the hypotenuse, they are the two sides making up the right angle itself. Theorem of Pythagoras defines the relationship between the three sides of a right triangle. So a square plus b square is equal to c square, where c is the length of the hypotenuse and a, b are the lengths of the other two sides. In a right triangle, the midpoint of the hypotenuse is equidistant from the three polygon vertices. A right triangle can also be isosceles if the two sides that include the right angle are equal in length. Right triangle with a given hypotenuse has the largest area when it's an isosceles triangle. A right triangle can never be equilateral since the hypotenuse is always longer than the other two sides. Any triangle whose sides are in the ratio 4:5 is a right triangle. Such triangles that have their sides in the ratio of whole numbers are called Pythagorean triples. There are an infinite number of them, and this is just the smallest. If you multiply the sides by any number, the result will still be a right triangle whose sides are in the ratio 3:4:5. For example, 6, 8, and 10. A Pythagorean triple consists of three positive integers a, b, and c such that a square plus b square is equal to c square. Such a triple is commonly written a, b, c, and a well-known example is 3, 4, 5. If ABC is a Pythagorean triple, then so is Ka, Kb, Kc for any positive integer k.